Okay, we'll start now. So welcome to What's Up over Edmonton for September 2022. My name's Jeff Robertson, and I'm a member of the Royal Astronomical Society Edmonton Centre. Before I start, I'm just going to say that last month I was talking about an upcoming surgery. Well, that surgery did happen 3 weeks ago today. And as a result, I'm kind of stuck in the house on the main level. And I can't go downstairs, and I also can't sit in a chair very long before my knee really starts to ache. So this, a lot of what you're going to see tonight, I did before the surgery. So it was done around the 8th of August. And some parts I just left out because I just felt I couldn't sit long enough to complete it. So let's get going. We always start with the view of the Queen Elizabeth Planetarium because the original view, or the original idea of this, was to hold these sessions live at the QEP, but the pandemic came along, the QEP never opened, and we've been doing it online ever since. And why didn't that change? There we go. I call this What's Up over Edmonton because the skies over Edmonton here at 53 degrees north latitude are quite a bit different than what you see in a lot of astronomical publications like Sky News, Astronomy, and Sky and Telescope. For example, this is the sky over Toronto looking south on July the 5th at 11 o'clock. And I point to this constellation here, Scorpio, where you can see the entire constellation from its head down to its stinger. Where in Edmonton, this is all we'll ever get to see. We'll never see the bottom part of that constellation. Also Sagittarius next door, we're never going to see the whole constellation of that one either. Most of the information I use comes out of the Observer's Handbook, which is put out by the RASC every year. It is 352 pages of just about anything you want to know as far as being an observer of the night sky. So what do we got for the sky in September? Good weather, longer nights, and falling leaves. Initially, when I did this, I had cooler weather, but obviously that's not the case right now. Looks like we're going to be pretty warm well past Labor Day. So we got Saturn up all night, beautiful sight, especially in a telescope. Jupiter reaches opposition this month. Mars is getting brighter, and it's best seen after midnight. Confined to the upstairs of my house, I have a lovely view of Mars about 3 o'clock in the morning. Right outside my bedroom window, I can see the orangey tint to it, and it's just because my knee sometimes hurts so much it wakes me up. We have the Autumnal Equinox, the beginning of fall on September the 22nd. That actually happens at 7:03 p.m. Mountain Time on the 22nd. And the sun has been really active lately. So always be on the lookout for aurora. You can subscribe to the Aurora Watch website, and they will send you alerts, yellow or red alerts, when the likelihood of aurora is likely. Sunrise tomorrow is going to be at 6:43. It will set at 8:23. And astronomical twilight ends, which means night begins, at 10:35. On September the 30th, at the end of the month, the sun is coming up at 7:34. It's setting at 7:12 p.m. And astronomical twilight ends at 9:09. So our nights are definitely getting longer. So this is the planetarium portion, and I taped this on August the 8th. So hopefully it'll play here. Let's start by looking at the planets for September. I've set the time here right now for 10 o'clock on September the 1st. So first out of the gate is Saturn. Now, If you were with us last month, you'll know that Saturn reached opposition on August the 14th. So 10 o'clock, it is well up in the sky in the constellation Capricorn. And even in a small telescope, even a 60 millimeter refractor will show you the rings of Saturn. Following the ecliptic down toward the horizon, we come to Neptune, a telescopic object, or if you have a good pair of binoculars, you'll be able to see it as a pale blue disk, and you might, in a mid-sized telescope or larger, catch a view of Triton, Neptune's big moon. And moving down the line, we come to Jupiter, shining very bright. Jupiter will actually reach opposition on the 26th of September, but even in the early days of September, it is above the horizon at 10 o'clock. Quite low. Best views will probably be after midnight, early in the month, and then as the month progresses, you can see it high up in the sky, blazing away a little earlier. Again, with a good pair of binoculars, you should be able to see, steadily held of course, the 4 Galilean moons. And on the night of the 1st at 10 o'clock, you can see all 4 moons. Ganymede on one side, then Io, Europa, and Callisto on the other. For the rest of the planets, we can see in the early evening, again at 10 o'clock. You have to go a little bit later on into the month to see Uranus. It is just peeking over the horizon at 10 o'clock on the night of the 16th. And in a telescope, it'll show a aquamarine, pale blue disk. And in binoculars, steadily held of course, it will show that very pale blue color. If you want to see Mars, you're going to have to stay up a little bit later, early in the month, actually well past midnight, or on September the 30th at midnight. Mars is above the horizon in the constellation Taurus, high enough that it would be easily seen, and it is getting brighter every month, and it is heading toward a very nice opposition on December the 6th. Through binoculars, Mars will have this definite kind of orangey pinky tinge to it, and with a medium to large telescope, you may be able to tease out some surface features on the planet even now, near the end of the month, through definitely through October and November, as the planet gets closer to the Earth and gets brighter, and you'll be able to see more and more features on the planet. 2 planets reach opposition in the month of September: Neptune on the 16th and Jupiter on the 26th. And of course, opposition is where the Sun, the Earth, and the outer planet are all in a line, which means the planet rises as the Sun sets. On the 1st of September, 45 minutes before sunrise, Venus sits about 4 degrees above the horizon. So if you have a clear, unobstructed view of the horizon in the east-northeast, you will be able to pick out Venus either with naked eye or definitely with binoculars. Fine, of course, the sky is clear. Venus is going to stay very low on the horizon for the next month and a half until until October 21st, when it reaches superior conjunction. That is when it swings behind the Sun from our point of view. And by the end of the month, this is the 30th, 45 minutes before sunrise, Mercury makes an appearance in the morning sky. it will rise higher each day until October the 8th, and then it will start to set again at the same 45 minutes before sunrise. So there we have the planets for September. Of course, our moon is always active in the sky. Here we have on the September the 7th, the moon pays a visit to Saturn. On the 10th, it forms a triangle between Neptune, which you'll see with your binoculars or telescope, and Jupiter, making a nice triangle there. On the 14th, it visits Uranus. And on the 17th, it passes Mars. September 22nd is the Autumnal Equinox, the official beginning of fall, when the sun rises due east and sets due west. And here is a representation of the sunset on September 22nd. And as contrast that with where the sun set on June 21st during the summer solstice, just 3 short months ago. As the Earth makes its yearly trip around the sun with its axis tilted at 23.5 degrees. On the equinoxes, the Earth receives equal amounts of sunlight both in the northern and the southern hemisphere, as seen here. So it's the beginning of fall in the northern hemisphere, it's the beginning of spring in the southern hemisphere. Some of the things to see in the night sky. Well, of course, the summer triangle kind of dominates the sky. Cygnus, which is one of the points of the triangle, is almost directly overhead, and there are lots of things to see within the triangle. And I know I've said this before, but the weather is good and the nights are dark, so have a poke around the summer triangle. Now Cygnus lies right along the northern Milky Way, so even if you just looked up at Cygnus, even in the city, with a pair of binoculars, you're going to see all sorts of stars as part of the Milky Way. And of course, if you go out away from the city lights, which we'll do in just a minute, you'll see lots more, and of course the glory of the Milky Way. And there is the Astrum of the summer triangle with Deneb lying right in the Milky Way, the very bright star Vega, and then the also bright star, but not as bright as Vega, Altair in the constellation Aquila the Eagle. Starting in Cygnus, easily seen in the city. If you zoom in on the head of the Cygnus the Swan, you will come to a double star Albireo, which does not show up in this simulation, but these are two fairly bright stars, and one is a nice blue color and one is a nice orange color. Going from Albireo to the left, we come to M27 the Dumbbell Nebula. In binoculars, it would look like a gray smudge. In a telescope, you can see some structure. Again, as I've said before, to the naked eye, our eyes don't pick up the color of ionized hydrogen, which is what gives these nebula and such the color, which is picked up in photographs, even on film. It picks up color where our eyes just can't see it. Bright star Vega points to a couple interesting items in the constellation Lyra. Of course, Vega is quite easy to see. It's one of the first stars you see once it gets dark. If you go to the right of it or up, depending on your point of view, you come to a double star Epsilon Lyra. But actually, now you need a pretty good telescope to do this, but if you split them, they're actually a pair of double stars, and there's one. You can see two stars there, and if we go up another pair of stars there. We refer to this star as the double-double, and it's not a coffee. Also in Lyra, or Lyra, is the Ring Nebula, which is the remnants of a sun-like star at the end of its life. In a mid-sized telescope, it's a very nice, it looks like a smoke ring. It's like a gray smoke ring. You're not going to see these colors, but you will see this kind of a donut in the in the sky. Going back to Cygnus, the bright star Deneb at the tail of the swan. Just to the right of it is this patch of sky called the North American Nebula, and there we go, because it kind of looks like the continent of North America. You can see the Gulf of Mexico there. Mexico. Yes, the North American Nebula. In a telescope, it's a faint patch of light. Now, so we've gone out to the country. We've got the crickets chirping here, and we're going to look at a few items you can see from a dark site. So the first one, we're looking in the northwest sky at Ursa Major, the Big Dipper. And if you follow the end of the handle and go almost straight down, maybe a little off to the left, or off to the right, I should say, you will come to this. This is M51. This is the Great Whirlpool Galaxy in Ursa Major, and of course you'll need a mid to large telescope to see it, but it's a spectacular sight. And that's not the only galaxy you can see in the constellation Ursa Major. A couple more galaxies in Ursa Major, messy objects. If you draw a diagonal line from the bottom left-hand star of the ball diagonally through the top right-hand star of the ball, go about 6 degrees, you come to two galaxies. Depending on the telescope you use, again, these are telescopic objects, come across M81 and M82. M81 is your classic spiral. M82 is a spiral viewed from the side, and it's sometimes referred to as a cigar galaxy just because of its shape. And if I turn on the labels, you can see there's all sorts of different Messier objects in and around Ursa Major, and if I click on the bright NGC objects, there's a bunch more. And I mentioned M31 the Andromeda Galaxy a few times in the past. Pretty easy to spot. You find the great square of Pegasus, and you find these two bright stars that are part of its leg, and just draw a line, and you'll bump right into it. And above M31 is M110, another spiral galaxy. Further away, definitely a telescopic object. And one other object I really like, it's I like to show it to people at public events out in a dark site because it's something that actually looks like what its name implies. And that is the owl cluster. And in a telescope, well, he's a little bit upside down, but it actually looks like an owl with its two eyes and its wings sticking out and its body. It's a neat object. And if I turn on the labels, there are, as you can see, there's all sorts of objects in and around M31, the Great Galaxy, Andromeda, and the Owl Cluster. As the sun comes up, I will say that's it for the planetarium session, and we'll ask for some questions. Before I go any further, are there any questions? Okay, we'll go on to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path every month of the year.
Okay, first quarter is on September the 3rd. The moon is full on September the 10th. And as it is the full moon closest to the equinox, it is known as popularly as the harvest moon. Has other names, the moose calling moon, the corn moon, the song moon, and the barley moon. Third quarter is on September the 19th. And the moon is new on the 25th. Now, of course, the harvest moon is probably the most popular name for the September moon because it comes up, it's very bright, and it helps the farmers get their crops off at night. Also, a peculiarity of the full moon in September, the rise times from day to day don't change a lot over a period of a few days. For example, on the 9th, the day before full moon, the moon rises at 8:23. On the night of the full moon, on the 10th, it rises at 8:35. On the 11th, 8:46, only 11 minutes later. And then on the 12th, it rises at 8:57. So that, having the moon rise up in the early evening all near around the same time certainly helps with the harvest. Instead of the usual time of 45 minutes to sometimes over an hour. For example, by the time we hit last quarter on the 17th, the moon is coming up at 10:45, and the very next day it's coming up at 11:33, so almost an hour later. I like to pick a feature on the moon that is from the RESC Observe the Moon certificate, either from the binocular or the telescope observer certificate. So I've picked a couple craters, and they're right in here, actually. These three craters here, but I'm only going to talk about two of them, just because of their appearance. And we call these the dumbbell craters. It's not an official name. It's just an unofficial name because these two craters there kind of look like a dumbbell. This is a picture I took, and admittedly I am the world's worst astrophotographer, so it is a little blurry. And there's a blow up of that. So you've got your one crater here and your other crater there, and you got this little ridge joining them, which kind of looks like the bar of the dumbbell. And this is a picture I took few days later. And the two craters are Cyrillus at the top and Katharina directly below it. And these two craters lie on the shore of Mare Nectaris, or the Sea of Nectars. Cyrillus is 98 kilometers wide. It's this guy here. It's 3.6 kilometers deep, and it's an old crater with eroded walls and peaks, as well as numerous secondary impacts that occurred after the initial crater was formed. Cyrillus was named after Saint Cyril of Alexandria, a 4th century Coptic pope, who was a theologian, and he was known for doing translations. Katharina is another very old crater right here. If it had a central peak, it's eroded away over the billions of years, and it contains a lot of secondary impacts. And it was named after Saint Catherine of Alexandria, an early Christian martyr. And this is a better picture taken from lunar orbit, and you can see Cyrillus and Katharina here. And you can see numerous impacts within the crater. If there was a central peak, and craters this size generally have a central peak, it's long gone here. There's a bit of remains of a central peak here. I don't think I said Katharina is 99 kilometers across and 3.1 kilometers deep. Now, there is a third crater here, right there, and that is Theapolis, and it's a fresher crater. So you can see its wall is kind of collapsed on Cyrillus is over here, and it has a rather prominent central peak. And again, all these three are right along the shore of the Sea of Nectar. Now, I didn't do a constellation this month. I just found it was too painful to sit in one spot for too long and work on that. So we'll have that next month, maybe, and I'll explain that right at the end. Okay, this is the space history section, and where we look at a past event that not only occurred in this month, or well, September, but whose anniversary year is divisible by 5. So in the year 2022, it's going to be years ending in 2 or 7. And I'm sure if you've read the papers or watched the news, you know that today was the 25th anniversary of the death of Princess Diana, because we have a 5-based number system. We got 5 fingers, we got 5 toes, we got 5 major body parts, so we like 5. You didn't hear anything about Princess Diana last year for the 24th, and I doubt you'll hear much about her next year when it's the 26th. But the 25th gets some ink. So, where were you in 72? Well, I know exactly where I was. September 28th, 1972. I was in a packed room in my high school, room 222 actually, and I was skipping my physics class, watching a TV set showing live via satellite Paul Henderson scoring the winning goal in the 72 Canada-Russia series. It's one of those events that's burned in my memory, like the Challenger disaster, 9/11, or the assassination of President Kennedy. But this was a good thing. So this is one of the few things that was good that I remember exactly where I was when it happened. But that's not what we're going to talk about. We're going to go 10 years earlier. So as the ad for American Graffiti said when it came out, where were you in 62? So going back 10 more years plus one day, we're going to 1962, and we're going to talk about this guy here, this satellite. And this satellite is Alouette 1, which was Canada's first satellite. And Canada was the third nation to build its own satellite after the US and the USSR. It was named after the French word for skylark, and also that song that we learned when we were all kids, Alouette, Gentil Alouette, etc., etc. Alouette 1 was designed to study the ionosphere from space. Now, the ionosphere was very important, especially in a land as vast as Canada before the age of communication satellites, because the only way to reach remote areas was by radio communication and by bouncing radio waves off the ionosphere. It was the only way to reach remote areas. It took from conception to launch, it took 3 years to design and construct Alouette 1. It, as you can see, it was about the size of a dishwasher, and it weighed 146 kilograms. Let's flip my page here. And it was powered by 6,500 small solar cells and contained 4 instruments. So here's a cutaway. There's batteries, there's solar panels, there's these sounding antennas, which I'll talk about a little bit later, and the telemetry antennas, which stick out the top. It was heavily shielded for radiation, which was a good thing, because after it was in orbit, the United States tested a nuclear explosion in space. And if the satellite hadn't been shielded properly, the electromagnetic pulse that came off this explosion would have probably fried its electronics. But it was heavily shielded because they were expecting, well, they didn't really know much about the radiation in the early days of the space age, and so they shielded it as much as possible. So it had 4 instruments. One was called the sweep frequency sounder, which measured electron density distribution in the ionosphere by measuring the time delay between the emission of a radio signal and the return of that pulse. Also had an energetic particle detector, which was basically Geiger counters to measure the amount of radiation in space, and a very low frequency receiver. And this was an experiment for measuring both artificial and natural very low frequency signals. And it was sensitive to frequencies between 400 and 10,000 hertz, which is fairly long wave radio. And then a cosmic radio noise experiment, which was 2 long radio antennas used for detecting radio noise from the sun and the and from other parts of the galaxy. Now, for that experiment, it used 2 very, very long antennas that had a very unique design. How long were they? One was 45 meters long and the other one was 23 meters long. Now, how did you get something so long stuffed into this satellite that's about the size of a dishwasher? Well, they had a rather unique design for this. They used beryllium copper wire, and it was slightly curved, and then it was rolled up like a tape measure. So when it was deployed, the satellite was spinning when it was deployed, and the antennas would come out at the side and extend just from the centrifugal force of the satellite spinning. It was a very unique design. It was the very first time anything like that had been tried. It was very, very unique. NASA was quite impressed with that design. Now, the satellite, if you look at this cutaway, it didn't have a tape recorder on board to store data. So it was only possible to receive the data when the satellite was within range of a receiving station. So on September 29th, 1962, Alouette 1 was launched on a Thor Agena rocket from Vandenberg Air Force Base in California. Its orbit naturally would pass over Canada. It was inclined at 80.5 degrees, and it was a fairly high orbit. It varied from a perigee of 985 kilometers to an apogee of 1,020 kilometers. So it was fairly circular, but it was fairly high. Now, it was hoped the satellite would function for a year, but it was thought it would only last 3 months at most. Back in those days, satellites didn't last very long. Well, on September 30th, 1972, 10 years plus 1 day after it was launched, it was felt that, oh, hang, someone just came into the thing. Let me just admit them. 10 years and a day after it was launched, it was determined that all the data Alouette 1 was going to provide had been obtained, and the satellite was shut down. So 10 years, not bad for 1962. It remains in orbit to this day, and it isn't expected to deorbit for several hundred years. At the time, it held the record for the longest operational satellite in orbit. More than 280 scientific papers were generated from the data it provided, and it really showed what Canadians can do when given the opportunity. Now, one of the men standing by this mock-up of Alouette is have his hand on that little top plate there, and I thought, well, maybe that's where they kept their drinks. But here are a couple of the project leads celebrating the success of Alouette 1. Now, there is a book called, let me see, after I stop the share, I'll hold it up. I'm just going to dig it out of my basket here. Okay. There's a book, and I'll show you, that has a lot of information on Alouette, and I used a lot of it for this presentation. So that's Alouette 1, Canada's first satellite. I think it's the only time I've talked about Canada in the history section. So cheers to us. Heavens Above is a great source of information. It has interactive star maps. It has satellite maps, passes, comets, just about anything you could ask for, astronomically speaking. The next What's Up is going to be on Wednesday, October the 5th at 7:30. After our summer break, the next RASC regular meeting is Monday, September the 12th. It's still going to be online. We're hoping this will be our last online only meeting, and we hope to be moving back to the TELUS World of Science in the Ziegler Theater for October, and that'll be the third Monday in October. Normally we have them on meetings on the second Monday, but that's Thanksgiving in October, so we'll have it on the 3rd. And we're also planning on live streaming it also. So if you can't make it to the meeting, you can still watch it there. Now, introduction to stargazing. I mentioned this last month. Alistair is stepping away from that. Berta says she's going to take it up. I haven't talked to her because I think she's just getting back from her vacation in Europe. But we're thinking of combining introduction to stargazing with What's Up. But we'll see how that goes. So with that, I will say thank you. And if there are any questions, oh, I see one chat here. I'll just stop the share first off here. And where'd the chat go? Chat. Frogs in spring, live on the lake, don't hear much. Great presentation. Oh, thank you very much. Thank you very much.
I've got a question.
Yep.
I was out looking at the Aurora last week, and I thought I'd take some pictures of it. and I noticed that the colors in my camera looked a lot better than the colors I was actually seeing. Can you explain that a little bit?
It's because our eyes see a very limited spectrum, where a camera sees further into the optical spectrum. That's probably why. And if it was a time exposure, your aperture is open a bit longer and it gathers more light, so it'll look brighter and you'll pick up fainter colors.
Can I use filters on my telescope to help show any nebula or anything? Does it enhance it?
Yeah, there are some filters you can get. There's something called an oxygen 3 filter. There are things just called like a light pollution filter you can put on, and that helps bring out certain features. It won't make it brighter, it'll actually make it dimmer, but it'll bring out certain features that you can't see. An O3 filter, I've got one, and it geez, I bought it like 20 years ago. It was over $100 back then. I don't know what they are now, but if you check All-Star Telescope, because they are in Edmonton, they'll have prices on their website, I'm sure. Oh, and that book is, let's see here. It's called Canada in Space. Oh, it's backwards. Anyway, it's written by Chris Gaynor. He's a former president of RASC National, and he's written quite a few interesting books on aviation and space with a Canadian bent to it. Another book of his I have is called Arrows to the Moon, and it just talks about after the cancellation of the Avro Arrow, what happened to all the engineers and scientists that were working on that project and how they went on to help NASA put people on the moon. And he's got another one out, came out last year. I haven't been able to find a hard copy of it. I've only found it online, and it's about the history of the Hubble Space Telescope. So.
Hoping to see everybody out at Black Nugget here in 3 weeks.
Yeah, I probably won't be out there because I don't want to be pushing around on that ground with a walker. I'll still be using a walker then. My wife said maybe we should go out there for the day. I'd like to go, haven't been to one since 2019 because really they didn't have one in 2020, and they had a kind of a scaled down version last year. But this year, they'll have the big tent, they'll have the speakers, they'll have the burgers and hot dogs after, and then observing. But I won't be sticking around for that because my knee isn't strong enough to lift a 45-pound telescope out of the car. So next year for sure. When I'm a little better, I'll haul it out to the backyard, but probably won't be till winter before I can get out of town with it. So it's a long road back, but yeah. Yeah. So, yeah.
Yeah. You said that Alouette 1 is still in orbit around the Earth.
Yes.
Does anybody try to communicate with it, say every year or two, to see?
No, they turned it off. They just turned it off. They deactivated. So it's just basically now space junk.
Oh, really? Because it had solar panels on it, so.
Yeah, well, after 60 years, I'm sure they probably degraded. I don't know how much power they put out anymore, but no, there'd be no way to communicate it with it any longer. No. It's it's just like the moon rovers. Well, they're battery powered, so they would have run out. But like the experimental packages on the moon were nuclear powered, and they just turned those off when they ran out of money to operate them. And I don't think once you turn it off, there's no way to turn it back on again. So
it would just seem to be extremely interesting to know how long it stayed in operation.
Well, 10 years is, for something launched in 1960, 60 years ago, that's pretty good. Like Sputnik only lasted, a matter of weeks because it was strictly battery powered, and it was in a fairly low orbit. So and then it just re-entered the Earth's atmosphere. And Explorer 1, the Americans' first successful satellite, it was battery powered too. And so it transmitted its data for a few weeks, and it went dead. But it's still in orbit too. It's in a really high orbit because it's the one that discovered the Van Allen radiation belts, and they're thousands of miles above the Earth. So it was in a really high elliptical orbit, and it's still up there.
Yeah.
Okay, if there's nothing else, oh, I see a couple chats here. Hang on. Let's see what we got. Thanks for presentation. Okay, heard about James Webb and its future expiry date. Something about hydrogen usage, maybe. Oh, it's got some maneuvering thrusters on board, and it has to fire those every few weeks because it's at Lagrange point 2, but it's not sitting in Lagrange point 2. It's actually orbiting Lagrange point 2. And every few weeks they give it a little puff of propellant just to keep it in that same orbit. So if you can imagine like a point in space, and this thing is just going around and around and around like that, that's what it's doing. So eventually that fuel will expire, and then the telescope will no longer stay in orbit, and it has reaction wheels, which is how they point it, but it will just kind of drift out of Lagrange point and start to heat up from the sun and that. But that's not going to happen for several years. So Webb's going to be with us for a long time. So not to worry about that. That's that. Okay, if there's nothing else, I'd like to thank everybody for joining us on this hot August night. That's the name of a Neil Diamond album. I used to have that on 8-track. And I hope you all have a really good September, and hopefully we'll see you again on October the 5th, or at the first RASC meeting of the fall on September 12th.